I would like to present an inquiry approach to learn evaporation, a subject matter that can be quite abstract to some students. What is evaporation?
Evaporation is a process in which a liquid gains heat and changes to a gas. In particular, water changes to water vapor through evaporation. Water around us evaporates all the time over a wide range of temperatures. It is one of the crucial processes responsible for the water cycle, alongside condensation and precipitation.
Based on my relevant experience working with students, I feel that the outcome of evaporation is not difficult to apprehend.
Indeed, a puddle of water around us always disappears, which we can see visually. It is the heat gain associated with evaporation that is somewhat harder to perceive.
I would recommend an inquiry approach to empower our students to construct the desired heat gain concept based on relevant experimental data. First, insert a temperature sensor into a cover made of cloth. Do likewise with another temperature sensor. Next, insert one of the sensor with cover into a temperature sensor holder. Then, submerge the other temperature sensor with cover into tap water at room temperature before inserting it into the temperature sensor holder. Now, obtain the temperature readings over a period of 5 minutes. Observe that the temperature reading for the sensor with wet cover kept decreasing, while that for the dry cover remained more or less constant. Why is that so? This must have something to do with evaporation, but exactly in what way?
Well, we need to come up with a set of inquiry questions to enable our students to construct the desired concept in a step-by-step manner based on the experimental data collected. Question 1 involves a desired subject matter knowledge, which helps set up question 2. Question 2 demands the students to account for the data collected. It may not be so straightforward for some students, as the water gained heat, but the temperature readings kept decreasing. Question 3 is about the control of the experiment, which is often necessary in order to confirm whether a particular variable indeed affects the outcome of the experiment. Question 4 tests the ability to apply the concept constructed.
Now, let us probe deeper by submerging the two sensors with covers in water. Then, insert them into the temperature sensor holder, this way. Only one of them is subjected to wind, but not the other. The outcome is that the temperature reading associated with the one subjected to wind decreased significantly more. What can the students learn from the data obtained? Last but not least, conduct the same experiment again, but submerge the two temperature sensors with covers into warm water instead of tap water. The temperature difference at the end of the data collection is larger than the previous case in which the sensors were submerged in tap water.
In any case, inquiry questions that help scaffold the learning is very essential. These are the experimental data recorded. Question 1 requires the students to link the data recorded to the rate of evaporation. Question 2 demands the students to deduce a factor affecting the rate of evaporation and how this factor influences the rate. One of the experiments involved water at room temperature, and the other experiment involved warm water at 50 degrees Celsius. The students would need to be aware of this before answering question 4. Part A of question 4 involves a straightforward calculation of the difference in the two temperature readings recorded in Table 1 and Table 2. Part B then requires the students to deduce another factor influencing the rate of evaporation. The students would have to make use of the values obtained in Part A and be aware of how they are linked to the rate of evaporation, somewhat similar to what they did for question 1. Question 5 is a concept application question.
I hope you find this inquiry approach meaningful. Thank you very much for your attention.